Hi, it's the official science man here. I'm going to talk to you about the interesting and very intense discussion about dark matter. Now, you probably don't know what dark matter is, so I'm going to let you know. So, yeah, dark matter up here. Okay, when you think about dark matter, it's really just a discussion about velocities in a galaxy. So just pretend that this is a galaxy. Not all galaxies look like that, but anyways. Scientists looked at galaxies, and they wanted to look at the velocity that, a star had with respect to how far it was away from the center. So the equations governing this are pretty much, there's two things. Like let's say a galaxy over here, or a star over here. It's going to have one force from gravity and then one force outward, which is pretty much the force that anything gets when it's spinning. There's an outward force because it wants to keep going in the same direction, but it has to keep going in a circle. So there's an outward force and an inward force. And these forces are balanced in order for it to go in a circle. If they weren't balanced, then either it would go this way or it would go inward towards the center and be, collide into the center of the galaxy. So those forces are equal. So when you solve for the velocity given those equations, you get something like this. Well, you get this. So this big G is just a constant. It's gravitational constant. Nobody really understands that too well. mg stands for the mass of the galaxy, r just stands for the distance, and v is the velocity. So what scientists expected to see was something like this. When you start at the very center and you go out a little bit, there's a very high mass density. So your mass shoots up a lot and your radius does not go up that much, so therefore your velocity goes pretty high. And then as you start to go towards the middle, it kind of wiggles up and down. Not too crazy, but it's kind of like staying in the same level because you're going further out, which decreases your velocity, but you're also gaining more mass. So it's kind of steady. And now what they expected, when you get further out, like over here, they expected a drop like that. You expect eventually your velocity to drop. But what they found is actually it continued to go and just level out. So this is theoretical, and that's what they actually found. So the reason this is weird, and they call it dark matter, is because although you're getting further out, which is decreasing your velocity, they're finding that there's actually a lot more mass there than they expected there to be. So that's the dark matter aspect of it. Because in order for this to be constant, your radius increases as much as your mass increases. But scientists cannot find the amount of mass needed for this to be so. They can't find the mass required to keep this ratio constant. So that's why they dub it dark matter. Scientists can't detect it now. Maybe in a few years they'll be able to detect it. There's a few hypothetical theories as to what the dark matter could be. Or it could just be some mass there that, I don't know. It's a very controversial thing right now. And actually considering the mass in the universe, or the energy in the universe, because if you know E equals mc squared, mass is energy. Dark matter accounts for like 15% of the energy of the universe, whereas normal mass that we see only accounts for like 5%. So dark matter is very big. There's a lot of it throughout the galaxy, throughout the universe, but we just can't detect it yet. So that'll be exciting to see when that gets settled.